Hi, hello, namaste. Welcome to the channel. Did you know that almost every coding interview tests array first? If you don't understand arrays deeply, topics like sorting, searching, dynamic programming, and graphs become much harder. In today's video, I'll teach you arrays from absolute basics with clear explanations, visuals. So let's begin. So before going into the main topic arrays, let's first know about what is a variable, what is a constant, and what is a data type. So a variable is nothing but, think of a variable as a labeled box, okay, inside a computer's memory. You give the box a name and you drop a single value inside it. That is called a variable. That means simply saying it as a space to store a single value. It might be of any data type, like it might be an integer, character, whatever it is, you can store in that. It is a space to store something. And coming to a data type, the computer needs to know what kind of value you're putting in that box, right? So it knows how big the box needs to be. This is where a data type comes in. So the data type is a classification that tells the computer what kind of data you're storing and how to interpret it. Let me explain you through a image. So this is how the types of data types are subdivided. So the data types are subdivided as initially with the two types. One is primitive data types and the other is non-primitive data types. Generally, the primitive data types are divided as four types: numeric, character, Boolean, and other. The numeric is subdivided as integral, floating point. Initially, the integral consists of byte, short, int, long, and the floating consists of float and double. Character is represented as char, Boolean is represented as Boolean, and this Boolean just returns the value as true or false. And the character is consists of characters like alphabets, okay, letters. It consists of them, and the floating point consists of points like 19.99. Can you see the example? Yeah, that is how the floating point is. That means it consists of decimals. And coming to the integral, this consists of byte, short, int, long. These all are integers, but the space or the storage capacity they have is how they are subdivided. Then comes the Boolean, which is returning the true or false. For example, Boolean is said to be like, for example, if I say that if this number is prime or not, after you code it, the answer will be a Boolean. If it is true, if it is a prime number, then it returns true. If not, it returns false. It is just a true or false case, that's all. And the string. The string is collection of characters. Here you can see, right? This D is a character, A is a character, T is a character, and A is also a character. And this string can be explained for further in a special video, and that is a continuation video of this arrays classification. Next comes the array, the main topic. It is of string, integer, like that. This is consists of fixed size collection of same type. That means the array is a data structure that lets you store multiple items of the same data type together under a single name. So what is an array? Array consists of a group of characters or integers or something, any data type that is of same type. If you, for example, let me say that if you want to store marks of a student, then all of the marks are numbers only, integers only. They're not like some person's marks doesn't consist of A, B, like that, right? So if you want to store marks, you should say that I want to store an integer array, integer values of some variables into a block, so that they never skip from accessing. And then comes the class and interface. These are separate topics which should be dive deep into. And then comes a list, set, map, queue. These are an advanced topics. Once you get into arrays, you will get to know more about them. So why arrays? That's the point now. Why do we think we need to use arrays? So let me tell you the problem which gave the solution as arrays. The problem is, if you want to store the test score of 5 students using standard variables, if I say I want to store 5 students scores into the variable, okay? Okay, so if I say first person marks are 45, the second person marks are 89, the third person marks are 34, fourth person marks are 34 and 12. Let's think whatever marks, and you give it as names as some R1, result 1, R2, R3, R4, and R5. Then you'll access this in wherever situation you want. So this is fine for 5 students. But what if you have 1,000 students? Creating 1,000 separate variables would make your code a massive, unreadable nightmare, right? So the solution is arrays. So the solution is arrays. Instead of 5 separate boxes scattered around, an array is a single chest of drawers where all the drawers are glued together in a straight line. So this is how you do it, right? So let me say that. So let me say this is for this one. Score 1 is R1, score 2 is R2, score 3 is R3, like that. These are scattered everywhere. But when it comes to arrays, this score 1, score 2, score 3, etc. are stored all in one place. Why do you think so? Because the arrays are contiguous memory allocation. So before going deep into contiguous memory allocation, let's say why, how, and where do we use them? Arrays. Coming to the why, the answer is we use them to organize large amounts of related data efficiently without cluttering our code with thousands of variable names. Okay? And coming to how, you declare one single array variable, tell the computer the data type it will hold, and specify how many slots you need. And coming to where, you see them everywhere, from sorting the list of songs in a Spotify playlist to holding the pixels on your screen to tracking high scores in a video game leaderboard. Let's dive into topic 2, that is memory representation. Coming to this memory representation topic, you need to know about RAM. What is RAM? It is your computer's temporary high speed playing field. And every time your programs run, it grabs a chunk of RAM to store its data. Think of RAM as a giant grid of tiny storage slots, where every single slot has its own unique numeric address, just like houses on a street. Arrays have one golden, unbending rule. When they sit inside this memory grid, they must be stored in contiguous memory locations. So, what does this contiguous mean? It means side by side with absolutely no gaps. If you ask for an array of 5 items, the computer must find a place in RAM where 5 empty slots are lined up perfectly in a row. It cannot scatter them. So, let me show you this. This is the memory representation of array, the contiguous memory locations. How it looks under the hood? Look at the diagram above. Notice the memory address at the top, which is 200, 204, 208, 212, 216, 220, etc. etc. Did you observe something? A standard integer usually takes up to 4 bytes of memory. So that is why this 200 is incremented to 204 and 208, 212, etc. from starting from the 0 index to nth index. If every first item is placed at memory address 200, it completes the slots as 200, 201, 202, and 203. Therefore, the next item must start exactly at address 204. The item after that starts at 208, and so on. So that is why the 200 is jumped from, the index 1 is jumped from 204 to 208, 208 to 212, 212, etc. Next, coming to the base address. What is base address? The computer doesn't actually memorize the address of every single item in your array. Okay, it only memorizes the location of very first item. This is called the base address because the memory is perfectly contiguous and every element is exact same data type size. The computer can use a simple math formula to instantly calculate where any item lives. So, coming to the formula, the address of element is equal to base address plus index into size of data type. So, for example, if you want to find the item at index 3 from this above diagram, what would you do? The address is equals to 200 plus, which is the base address. That means the initial address where the variable is stored or the array first element is stored is 200. That's address. And 3 into 4, which is equals to 200 plus 12, which is equals to 212. How did you get 212? So the index which we are finding is 3. So since we were thinking about the index of 3 and we know that it is an integer data type array, that means every element has 4 as its size, and this is the base address. So calculating using the given formula, we get the output as 212. Can we see at index 3 that its address is 212, right? So this is how the formula is used. You can check it for any number. That is why this array is considered as contiguous memory. Going to the next point, that is the static versus dynamic arrays. So in this, I'll cover static versus dynamic arrays explained clearly, memory, compile time, runtime, and resizing. So let's dive into this topic. This is a very important topic when it comes to DSA series. In the previous concepts, we learned what arrays are and how they are stored in contiguous memory. But now we're going to answer a very interesting question. That is, what happens if an array becomes full? What happens if an array becomes full? Because I've said that in this above picture, you can see that the array is initialized with the n elements and n index is given, and this is already created, initialized during when the array is initialized. The size is given. What if a 12th element, sorry, the 13th element enter into this array? What happens? Since it is already filled, what happens if the extra element comes in? So imagine you're developing Instagram, WhatsApp, PUBG, or YouTube, something else. Can you predict how many users will use your application? Of course not, right? Sometimes you may have 10 users, sometimes 10 million. So, how can an array handle this changing amount of data? That's exactly what you'll learn now. By the end of this topic, you will understand static arrays, dynamic arrays, compile time, runtime, memory allocation, how resizing actually works, why Python lists and JavaScript arrays are called dynamic arrays, interview questions on this topic. Let's begin. So first thing is, why do we need two types of arrays? Imagine you're organizing chairs for a seminar. Okay. Case 1. You arrange exactly 100 chairs. Okay. And there comes a special guest who is a latecomer, and he is the extra one person who doesn't have chair. And now the total is 101 people arrived. That one person has nowhere to sit. Then the second one. Only 20 people arrived. Out of 30. Sorry, only 20 people arrived for the event. And you arranged 100 chairs. What about those 80 chairs? This is exactly the problem with arrays. Sometimes we allocate too much memory, sometimes too little. To solve this kind of problems, programming gives us two different approaches. One is static, the other is dynamic. These are the two kinds of approaches to solve the above problems. Before understanding them, we must first understand two important concepts: compile time and runtime. Here comes about compile time. Did you ever heard about the compile time or word compile time? If no, let's learn here. So, many beginners confuse between these two terms, compile time and runtime. Many beginners confuse between these two terms. Let's understand them with a real world example. Suppose you are writing a C program. When you press the compile button, your code is not executed immediately. Instead, the compiler first checks syntax errors. Then it goes to variable declarations. It checks whether the variable declarations are correct or not, and then the data types. Then it converts your program into machine language. This entire process is called compiling. And the compile time is like, think of compile time as preparing food. Cooking happens first, only after cooking you can eat. Running the program is like eating the food. That's called runtime. Coming to the definition of compile time, it is the phase where source code is translated into machine language or machine code before execution. This is a pure definition of compile time. Okay. Coming to this runtime, this can be defined as the phase where the program is actually running. Did you get what is the difference between compile and runtime? Okay, then let's dive deep into static arrays. A static array is an array whose size is fixed before the program starts executing. For example, let me tell you, I'll be initializing an array. I'll be initializing an array whose size is 5 and its name is marks. So here you can see that this is the data type, this is a variable or the array name, and this is the size. As I have written this in a C language, this should contain a semicolon. This is the syntax. Okay. As the definition says, a static array is an array whose size is fixed before the program starts executing, once created. It's never changed. Here the compiler reserves memory for exactly 5 integers only, since we have given a size of 5. Even if you need 100 elements later, you cannot increase it to 100. This size as 1. Let me say that this is elements which consists of 1, 2, 3, 4, 5 and whose index start from 0, 1, 2, 3 and 4. Since the index starts from 0, the nth element index will be n minus 1. This should be a point to be remembered, since it can happen an index out of bounds error also. So that's a main point. And example for this could be, suppose you're building a classroom attendance system. Okay, maximum students is 60. Then you create int students of 60. Okay, everything works perfectly, but next year admissions increase. Now there are 75 students. Can the array become 75 again? No. You will have to create another array that says int student 2 of 75. Is this okay to create the arrays again and again? No, right? So let's take another example. Suppose only 10 students join. So what I'm saying is, you have created an array for 60 students and the students who joined were only 10. What do? The remaining 50 seats are empty. Only 10 are used, the remaining 50 are wasted. So for static, advantages are, it is simple. Since you don't need any large syntaxes or complex syntaxes which cannot be remembered, it's simple to create an array using static, and it is fast. Since the size is fixed, the accessing is fast. You know every element till end, and the memory is allocated once. No resizing. Cache performance is excellent. This is all about the advantages of sorry static array. Coming to the disadvantages, it cannot grow, right? As we discussed above, it cannot shrink. Memory wastage is more, and overflow problem. There is the entry of dynamic here. So, in order to explain dynamic arrays, I would say to imagine a magical array. Whenever it becomes full, it automatically grows. This is called dynamic array. Funny, right? So, let me tell you clearly. The dynamic array is an array that can increase or decrease its size during runtime. During runtime. Unlike static arrays, you don't decide the final size. The program handles it automatically. Like languages like Python, Java, JavaScript, C++, etc. use dynamic arrays. So for Python, the dynamic array could be list. For Java, the dynamic array could be array list. And for JavaScript, the dynamic array could be array. And for C++, the dynamic array could be a vector. So coming to the real life example for this dynamic array, suppose you are making Instagram. Initially, no users. So memory would be empty, right? Then one user followed you. How much memory it would take? Some A. We don't know how much memory, but it is A. Let A can be any number. How much space it requires? That much. Then two users. It might take A, B, memory. Then three. A, B, C, then so on, and the memory is also so on. Millions of users can join in this way. The array keeps increasing. So this is why a dynamic array is important when you don't know the size of the elements to add into your array. How can a dynamic array grow? Now comes the most interesting topic, that is how can a dynamic array grow? For this, my answer would be this. So for example, let us say the dynamic array is this way. Okay. Now comes the most important interview question. How can a dynamic array grow? Arrays must be stored in contiguous memory, right? Suppose memory looks like this, A, B, C, D. Okay. That means array is full. Now new element E needs to be inserted. Can the computer simply add E? No, right? What if the program already occupies that memory? There is no free contiguous space now. So what happens? The computer performs resizing. So the steps for resizing a array would be: create a new larger array. Initially, the old size will be 4. Since we have 0, 1, 2, 3, that means the length would be 4. Since we know that the length of an array is n minus 1, where n is a size. Now, the new array could be the size of 8. Then you can see 1, 2, 3, 4, 5, and so on, space to insert elements. 8 spaces will be left over. Then you copy every element from this array into this array. Then you can see that initially you have A, B, C, D, and you inserted E, and then the 6th index is empty, 7th index is empty, and 8th index and 9th index would be empty. Now, what you could do to clear the memory, to save the memory, you could delete this old array, which is finished, and the entire process happens automatically. The programmer never notices it. You might ask the question, why should we double the size? We could just add some other random number like 100 so that we could directly don't need to double the times again and again. And this is the same question interviewer asks often. Why not increase by one element? So if you think the current size is 100, okay, the new element arrives. It increases to 101. Then again another element arrives. Then what will you do? It will again increase to 102. Then again increase to 103. Then again this way. Every insertion requires copying the entire array very slow. Instead, dynamic arrays usually double them. This reduces the number of expensive resize operations and gives an amortized insertion time of order of 1. We'll be discussing about this order in the further classes. So this is what we discussed right now, right? So coming to the comparison of overview of these topics is static versus dynamic competition. Comparison topic is the static array is fixed and the dynamic array is resizable. The memory allocation for static array is compile time and for dynamic is runtime. We have discussed about compile time and runtime before itself. So the next thing is resize. Static array can be resized? No. Then dynamic array? Yes. It can be resized and there will be no wastage of space or memory in dynamic array. Performance is faster in static arrays than dynamic arrays. Usually the static arrays are used in the languages C, and the dynamic arrays are used in Python, Java, C++, JavaScript, etc. As I have mentioned here. You could see this, right? Yeah. Next, coming to the interview questions. Interview questions. The interviewers often ask the questions like explain about static array, dynamic array, and difference between compile time and runtime. Then comes the question which we discussed earlier, why can't static arrays grow? How does a dynamic array resize? Why is doubling used instead of increasing by 1? What is contiguous memory? And so on. These are the basic interview questions. that are asked during HR interviews or so these are the basic questions that are asked inside the interviews. Before we end this topic, let's go through some interview questions that companies frequently ask about static and dynamic arrays. These questions are common in placement interviews at TCS, Infosys, Accenture, and so on. Even if you're a beginner, make sure you understand the reasoning behind each answer rather than memorizing it. Let's take an overview about these answers. What is a static array? As I explained before, a static array is an array whose size is fixed before the program starts executing. Once the memory is allocated, its size cannot be increased or decreased during runtime. So the syntax for static array is int array name and its size. And once this size is 10, it cannot be modified. This array can only store 10 elements. If you need more space later, you cannot expand it. You must create a new array. Then comes the dynamic array. What is a dynamic array? A dynamic array is an array that can automatically grow or shrink during program execution. When it becomes full, it creates a larger array, copies the old elements into it, and continues storing new elements. And these are used generally in Python, C++, Java, etc. What is the difference between compile time and runtime? Is the third question. Compile time is the phase where the compiler checks your code for errors and converts it into machine language before execution. And what is runtime? When the program is actually running and interacting with the user, it is called as runtime. A simple way to remember this is compile time means preparing the program, runtime means executing the program. Then going into this why can't static arrays grow? Static arrays cannot grow because their memory is allocated before the program starts. Did you get it? The compiler reserves a fixed amount of contiguous memory. Okay. If more elements need to be stored later, there is no guarantee that the next memory locations are free. That's why the size remains fixed. How does a dynamic array increase its size? This is one of the most important interview questions, so listen carefully. A dynamic array cannot simply extend itself because arrays require contiguous memory. Instead, it follows these steps. Firstly, it creates a new array with larger capacity, as we discussed here. Firstly, it creates a new larger array and then it sends the copy all and then secondly it copies all existing elements into the new array. Then it inserts a new element and finally it deletes the old array from memory. This entire process happens automatically. The next question is, why do dynamic arrays usually double their size? Many beginners think a dynamic array should increase its size by 1 whenever it becomes full, but doing that would require copying the entire array every single time a new element is inserted. Instead, most dynamic arrays double their capacity. For example, 1 becomes 2, the size of array is 2, then it becomes 4. If it is 4, it becomes 8. In this way, this greatly reduces the number of resizing operations and makes insertions much more efficient. Then comes the main point, that is, what is contiguous memory? Contiguous memory means all elements are stored one after another without gaps. These values occupy neighboring memory locations. Because of this arrangement, the computer can directly calculate the address of any element, making array access extremely fast. There are extra questions which could be asked, so I'll be letting you know about them. Why are Python lists called dynamic arrays? Python lists are dynamic because their size changes automatically. If you keep adding elements using the append function, Python automatically increases the storage whenever needed. As programmers, we don't need to manually allocate new memory. Python handles the resizing internally. So, another question that could be asked is, what are the advantages of dynamic memory or the dynamic arrays? You know that, right? The biggest advantages are they automatically resize, they reduce memory wastage, they are easy to use, they are ideal when the amount of data is unknown. That's why most modern programming languages use dynamic arrays by default. The last question could be disadvantages of dynamic arrays. Although dynamic arrays are very useful, they also have some disadvantages, right? Whenever resizing happens, a new array must be created. All elements must be copied and the old memory must be released. This copying operation takes extra time. So while most insertions are very fast, resizing itself is relatively expensive. That is why we say that these static arrays are fast. Okay, so these were some of the most frequently asked interview questions on static and dynamic arrays. If you understand these concepts instead of memorizing definitions, you'll be able to answer confidently in technical interviews. In the next video, we'll move to the next topic and continue building a strong foundation in arrays. Until then, keep practicing and keep coding. See you in the next video. So, like, share, and subscribe to Gen Z Learn.